Well, the search for life on Mars has been a series of missions, and each one has added some credence to the possibility that we may have company in the solar system. And now, after a decade and a half of amazing discoveries, comes perhaps the most dramatic news yet. There's something underneath the surface of Mars that's generating huge plumes of methane gas. To help us understand what the methane means, I'm joined by Dr. Lisa Pratt, a professor of geological sciences at Indiana University. Now, Dr. Pratt, you are a geologist, so before we all get too carried away about this being life, can you explain to me what are the possible geological origins of this methane?
The most common way that that occurs is in a reaction called serpentinization, named for the suite of rocks that are formed by that reaction. Now, that requires exposing carbon dioxide, usually dissolved in water, to the kind of rocks that on Earth are only found in the mantle, and so are only rarely exposed to water near the surface. The places where we see it occurring on Earth are primarily in places where deep fractures and fissures have uplifted rocks from the interior and exposed them primarily on the seafloors, where we see this reaction on Earth.
And so why is it that so many people seem to believe that there is a biological explanation for the methane that's on Mars as opposed to these geological explanations?
Well, actually, I think the jury's still out. Either process is an equally good explanation because the methane is really very difficult to distinguish, whether it's forming biologically or geologically.
And how do we know that it's an active emission? Do we know that, or do we know that it's just been hanging around for a while?
Well, I think that's based on a number of assumptions. It seems that unless the process was ongoing, we would have long ago depleted most of that stored methane. So again, we're waiting for the scientists that have made this discovery to release additional information to tell us whether or not these releases are truly seasonal.
Would you say that in my lifetime we'll know with a reasonable amount of certainty that there is life on Mars?
Yes, I would think so, because although it's interesting to speculate about whether or not the source of the methane is biological or geological, it really doesn't matter in the sense that once you have methane, it's an extraordinary resource for organisms to consume. So the presence of the methane, regardless of its source, gives us a bullseye in terms of future exploration. We now know where to go and explore to see if there are life forms consuming that methane. And there really is no absolute definitive way to know until you recover a sample and can look at the active process and determine whether or not it's just abiotic chemistry or the chemistry of life.
Incredible stuff. Thanks so much for your time, Dr. Pratt.
Pleasure.
Now, if we're ever really going to figure out these plumes on Mars, some scientists think sooner or later it won't be enough to keep sending up little robots. We're going to need some boots on the ground.
I think it would raise the question, don't we really want to go there? Is our robotic presence enough? Even if science doesn't justify sending humans, wouldn't it be worth the trip? These are the questions. I'm not giving the answer. That's for people and the public to choose if they like that.
But it's not an easy choice. Getting human beings to Mars will be enormously challenging and expensive. Keeping them alive up there will be no small feat. Mars is an extremely inhospitable place. Winds can reach 80 miles per hour. Dust storms can flare up and cloak the entire globe from the sun for months. The atmosphere, over 95% carbon dioxide, can't retain solar heat. The frigid temperatures at the surface can go as low as minus 195 degrees Fahrenheit. Using instruments like MRO, scientists are trying to understand exactly what they'll be up against.
Someday, humans will move about the surface and live and operate. And one of the things that one will want to do is to be able to forecast changes that might adversely affect the way in which they work or even their health. And on Mars, that change is the rapid development of dust storms. And those dust storms can effectively reduce the sunlight on the surface. Certain kinds of vehicles that operate with solar energy aren't as efficient. It can make difficulty in seeing long distances. There's a lot of things you want to worry about.
And then there's the question of how we get there.
When we go to Mars, we are constrained by the position of the planets around the sun.
Though Mars is our nearest neighbour, it's still very far away. At their closest, the Earth and Mars are over 34 million miles from one another. And since the two planets move in different orbits at different speeds, they're usually even further apart. A manned voyage to Mars will have to be timed just right.
The window of opportunity to go from Earth to Mars or Mars to Earth opens up only once every 2 years. So a trip to Mars might involve taking 6 months to get there and then staying on Mars for 2 years. Part of preparing to send humans to Mars is to test out our equipment and procedures here on Earth.
Planning a trip to Mars involves living the life of a Martian right here on Earth. That's exactly what the Mars Society is doing.
The Mars Society is an international organization of people committed to furthering the exploration and ultimately settlement of Mars. We have simulated human Mars exploration stations in the Canadian high Arctic and in the American desert, where we can actually practice Mars missions and see what might work and what won't. The Mars Society has now run about 70 different crews between the Arctic and the desert station.
Through NASA's educational activities, we've been working with the Mars Society to encourage this sort of astronaut training.
I'm going to be in this position here. I'm going to be the geologist, and I'll be scouting for samples.
One of the most important things we do here is our EVAs, our extravehicular activities. When we go out for an EVA, we have to put on our spacesuits, depressurize in the airlock for 1 minute, and then go out and conduct our EVA. The airlock is important because we need to depressurize down to the pressure of the Martian atmosphere so that when we open the hatch, it doesn't explosively decompress.
Protection from the elements and the atmosphere is one thing.
Thanks, Patrick.
But if explorers are to spend months on Mars, they're also going to need to eat. Fortunately, as the Phoenix mission showed us, Martian soil could sustain life if you heated it up.
One of my interests is this notion that Mars could be made habitable once again. The metaphor I use is doing CPR on someone that's fallen over dead. Well, if that person has fallen over, but you can still detect a faint level of activity, a faint pulse, then you're certainly going to be more encouraged at the prospects of being able to revive them. Because Mars is so far away, we don't want to have to carry food with us. We'd like to be able to grow it there.
So we grow it using the Martian resources. The Martian Earth, the Martian atmosphere, which is almost totally carbon dioxide and nitrogen. Humans will die in the Martian air, but plants will live off the Martian air.
It may sound way out there, but some scientists are even talking about transforming the entire climate of Mars to make it hospitable for humans, heating it up using greenhouse gases. It's a process they call terraforming.
The basis of terraforming is the notion that early in Mars history it had life and it's recently dead. Recently for Mars means a couple billion years. We humans have learned how to warm up planets. We're doing it on Earth with super greenhouse gases.
Ironically, to possibly revive some form of life on Mars, we'd need to introduce the same conditions that are threatening life here on Earth.
If we establish human societies on Mars with significant industrial capacity, they could create these greenhouse gases there and warm the planet. It would cause the water that's frozen into the soil to start melting out, running again in the streams and riverbeds of Mars, filling the lakes and putting water vapor into the atmosphere. And water vapor is a greenhouse gas.
Mars will be the first test of what are our intentions as a species as we move out beyond the Earth. And so I think we need to ask the question, can humans survive on Mars? What are we going to do there? And where are we going to go from there? And maybe that's a question we're not going to answer soon, but I think we have to start working in that direction.
A manned mission to Mars may be some time off, but for now, the discovery of methane is forcing scientists to rethink the next generation of unmanned Mars observers, landers, and rovers. Coming up, we'll find out what the next steps are in the ongoing hunt for life on Mars.